Hello everyone, our focus for this video is the sum and difference formula, right? And we're still on trigonometry identity. So let's say you have an angle which is sine of A plus B. So you have two angles, right? And you want to add them. And you want to take the sine of it. What is this equal to? This is simply equal to sine of A of this angle cos multiplied by cos of B, the second angle, plus sine of the second angle here, which is B, multiplied by cos of the first angle, which is A. So these interchange, basically. What if it was sine A minus B? What do you think will happen? Same thing. This is going to be sine of A times cos of B minus sine of B cos of A. That's it. What about if you had cos A plus B? What was this equal to? This is just equal to cos A times cos B, because this is plus, it takes the minus sign here, which is minus sine A sine of B. So when you look at the cos and the sine, whichever sign is in here, that's what this side takes. But for the cos, it's slightly different. If there's a plus here, it's going to take minus. If there's a minus here, what do you think it's going to take? It's going to take a plus. And then it's slightly different here, where it does alternating sine cos, sine cos. For this one, it's just cos cos, sine sine. So it's cos A, cos B, sine A, sine B. Let's look at the difference. So let's say you have cos of A minus B. And I guess by now, you can just tell me what this is. So this is just cos A cos B, and this is minus, so this is plus sine A sine B. Alright? So these are the sum and difference formula. We're not going to look at the tan one of the sum and difference in this video. We'll look at that one in another video. Now, how is this formula helpful to you? Now, this formula is helpful to you when you're asked to calculate an angle without the use of a calculator, right? You can use this formula. All right. For example, let's look at an example. So let's say that on an exam paper, you're given two angles, right? And you're asked to calculate these angles without the use of a calculator. So you're asked to find cos of 15 degrees, and you're also asked to find sine of 75 degrees, right? Now, cos 15 degrees, they want you to find this angle without the use of a calculator. How would you go about this? What do you know that you can use to find this? Of course, you know about the special angles, right? Which is 30 degrees, 45 degrees, 90 degrees, 60 degrees, 180, and so forth. 360 and so forth. Those are the special angles. You can use these special angles to rewrite cos 15. Because cos 15 is just simply equal to cos of what? If you have 45 degrees and you subtract 30 degrees from it, that's just another way of writing cos 15 degrees, right? Because 45 degrees minus 30 degrees, that's just 15 degrees. So these two things are equal, right? And then from this, you can use the sum and difference formula. What's the sum and difference formula? What's the difference formula for cos of an angle? You know that, for example, here, you know, you would have cos of A minus B, right, is equal to cos of A cos B, because this is minus, so this is plus, sine A sine B, right? So that's the formula you know. Now, 45 is like your A here, and 30 is like your B here. So if you write this here and say, okay, cos 45 degrees minus 30 degrees, what is this equal to? This is just cos of 45 degrees, right, multiplied by, and here you can just put a dot, or you can just write it without it. So cos of 30 degrees, right, because this is minus, this is plus, so this is a sine of 45 degrees times sine of 30 degrees. That's it. But what is cos 45 degrees? Do you know it? Do you know what cos 45 is? Do you know what cos 30 is? Do you know what sine 45 is? Do you know what cos 30 is? Of course, you know it. In my previous video, you will learn about some special triangles, right? Now, we know if we have a triangle here, let's do a rough sketch. On this side, this is a 90 degree, right? So this is the hypotenuse, and we know that the length of this side is 1, and the length of this side is 1. And the angle here is 45 degrees, and the angle here is 45 degrees. Then we can calculate the hypotenuse, right? Because the hypotenuse is just equal to 1 squared plus 1 squared, and 1 squared plus 1 squared, that is 2. And when you find that, because that's just root 2, right? So this is just root 2. Because you know that the area, the hypotenuse square, is equal to the sum of the square of the other two sides. So that's where I get this root 2 from. So you want cos 45, right? Simple. Cos 45. So we know that cos 45 would equal to what? Cos 45. Just pick any one of them. I'm focusing on this one. So this would be the opposite. But we know that cos has to do with the adjacent. So this is just 1 over root 2. So here, this is just 1 over root 2. Again, we need, that's just cos 45. We need what? Sine 45 as well. So sine has to do with the opposite. So sine 45 here is just 1 over root 2 as well. Cool. What else do we need? We need 30 degrees, right? So from my previous video, you would have known about this triangle that you have, a right angle triangle, right? Which is the 60-30 triangle. So this is 30 degrees, this is 60 degrees, right? You know the length of this side here, which is 1. And you know the hypotenuse is 2. So that means this side is just root 3. Right? From this, we can find what sine 30 is, right? Of course. So we know that sine has to do with the opposite. So this would be opposite, where 1 is opposite to the 30 degrees. So here, sine 30 is just equal to 1 over 2. Right? So this is just the opposite over the hypotenuse. So that's just a half. And what else do we want? We want sine 45 as well. So, no, we have sine 45 already. We need cos 30, sorry. So cos has to do with the adjacent, which is this side. So cos 30 is just equal to what? This is just root 3 over 2. So this is just root 3 over 2. So that's all the information that we need. So all we need to do is to just sub this value here that we know. And by the way, you are expected to recall these naturally, but if you can't recall them naturally, you can just remember the triangle. That will help you. So all you need to do is to just replace these values here in this formula and just solve it. So we know that cos 45 degrees minus 30 degrees is therefore equal to cos 45. What is cos 45? Cos 45 is just 1 upon root 2. So this is just 1 over root 2 times cos 30. But what is cos 30? Cos 30 is just root 3 over 2, right? So this is just root 3 over 2. All of that plus sine 45. What is sine 45? Sine 45 is just 1 over root 2. So this is just 1 over root 2. Times sine 30. What is sine 30? Sine 30 is just a half. So that's that. Alright? So now we're finished with these. So all you need to do is to just simplify these, right? So if you simplify this, this will equal to, what is 1 times root 3? That is just root 3. What is root 2 times 2? That is just 2 root 2. Right? Plus, what is 1 times 1? 1 times 1 is just 1. What is root 2 times 2? That's just 2 root 2. Right? So this is a fraction, right? The denominator are the same, despite how it looks. So the denominator here is 2 root 2. Denominator here is 2 root 2, which means that these two fractions are from the same family. So all we need to do is we can just combine the top. So our final answer is just root 3 plus 1 all over 2 root 2. And that is our answer there. So our final answer is sine cos 15 degrees is equal to this. Is equal to root 3 plus 1 all over 2 root 2. Right? You could play around this and rationalize the denominator, but I will show you that that's just basically the essence. And that's how you would use the sum and different formula to calculate an angle without the use of a calculator. Let's just look at sine 75 quickly. So sine 75, we can rewrite sine 75 with a special arm, right? So we can say sine 75 degrees is therefore equal to, which two special angles can you add or subtract that gives you 75? This is just equal to sine of 45 plus 30, because 45 plus 30 equals what? 45 plus 30 gives you 75. Good? That's basically it. Now, here we can expand this part, because all of this we know is just equal to sine of 45 degrees cos of 30 degrees plus sine of 30 degrees times cos of 45 degrees. Right? Okay, we switch to the angles. So that's what's that. So that's what sine 75 equals. Now, do we know what these angles represent? Sine 45. What is sine 45? Sine 45, that's just 1 over root 2. Right? That times cos 30. What is cos 30? Cos 30 is just root 3 over 2. That's what cos 30 is. Right? Plus sine 30. What is sine 30? Sine 30 is just a half. What is cos 45? Cos 45 is just 1 over root 2. Right? Clearly. Now, all you need to do is just multiply. These are two fractions, right? So, 1 times root 3, that's just root 3. Root 2 times 2, that's just 2 root 2 plus 1 times 1, that's just 1. 2 times root 2, that's just 2 root 2. Now we can add these, right? And if we add this, then our answer is root 3 plus 1 all over 2 root 2. So therefore, we can say that sine 75 degrees is equal to root 3 plus 1 over 2 root 2. And note here that basically sine 75 is equal to cos 15. Why? 75 and 15 are complementary angles. And we know from my previous video that whenever you have the sine of an angle and the cos of another angle, and when you add those two angles and they are a complementary angle, then the result should be the same thing. So both answers are the same. Now, sometime if you have a calculator like mine, you can put sine 75 on it and it gives you the answer in series. But what it would do, it would give you this answer after the calculator has rationalized the denominator. So let me just show you. So this is our answer here. And let's say I don't want this root 2 to be a part of the denominator. So what you can do is to rationalize the denominator by multiplying both the numerator and denominator by root 2 over root 2, right? If you do that, here, you have to visualize that all of this, it is root 2 times all of the numerator. So this is a bracket, right? And you distribute normally. So your final answer would be root 2 times root 3, that's thus root 6, right? Plus root 2 times 1, that's thus root 2. All of that divided by root 2 times 2 root 2. If you, this 2 root 2 means 2 times root 2. So this, I could take this 2 and put it here. Times, and multiply root 2 times root 2. Root 2 times root 2, that's just root 4. But what's the root of 4? That's just 2. So here, I would end up with 2 times 2. But what's 2 times 2? 2 times 2 is just 4. So this is just 4. And the final answer is just root 6 plus root 2 over 4. So these two things are equivalent. That's the same thing, right? So if you have a calculator like mine, and let me just show you. If you have a scientific calculator like mine here, what it allows you to do, you can just put sine, you just select sine on your calculator, and this is a sine, and you put sine 75 on your calculator, so sine 75. And you press equal. Your answer will be root 6 plus root 2 over 4. That's it. I have it on the board there. But what it has done is to rationalize the denominator. So yes, for some calculator, it can help you to get the answer. But remember, they want you to show how you would get the answer without the use of a calculator here. So this is the skill that you need. Alright. Sine 15 degrees. And you're asked to calculate this without the use of calculator. So simple. This is basically sine of 2 angles. Now we can use 60 minus 45, right? Because 60 minus 45, what's that? That's 15. We could use 60 minus 45. We could use 45 minus 30 because that's still 15, right? So it doesn't matter which one. But this is also equal to this as well. So let me just write it down. This is also equal to sine of 45 minus 30. The same thing. Both of them, if you subtract both numbers, you get 15. But what we are going to do, we're just going to zoom in and the 60 minus 45 for this example here. So again, use your double angle, your sum and difference formula. This is a difference. So this would equal to sine of 60 cos of 45 minus sine of 45 cos of 60. So the angle alternates, right? Do you know what sine 60 is? Yes, you know. Sine 60 is just root 3 over 2. Multiply by cos 45. What's cos 45? That's just one. Let's use root 2 over 2 this time. So that's just root 2 over 2. Alright? What about sine 45 here? That's just root 2 over 2. Alright? And what is cos 60, right? Cos 60 is just one over 2. That's just a half. Alright? So now all you need to do is to multiply this and simplify, and you're done. So root 2 times root 3 times root 2, that's just root 6. Right? 2 times 2, that's just 4. Minus root 2 times 1, that's just root 2. 2 times 2, that's just 4. Right? Here, the denominator are the same, so this is just root 6 minus root 2 over 4. So we're saying that sine 15 degrees is equal to this. And that's how we'll do it without the use of a calculator. Now, let's just use our calculator to test to see if this is actually true. Right? So now we know we want to find sine 15. So it is a sine, S-I-N, and then you put 15 on your calculator, close the bracket, and press equal. And it says our answer is root 6 minus root 2 over 4. So absolutely we are correct. And that's how you would do it without the use of a calculator. Alright? Thank you for watching, and do enjoy the rest of your day.